Let's look at an example of contingency tables and also how to do conditional probabilities. So in this scenario, suppose that 50% of different trail mixes at Trader Joe's have peanuts, 30% have raisins, and 25% have both peanuts and raisins. What is the probability that a randomly selected trail mix has peanuts given it has raisins? And I'm going to start with sort of the picture way of going at this, which is a contingency table. And here's the idea behind a contingency table. I'm going to have columns that represent one of my events. So in this case, I see some things have peanuts. And by extension, that means that some of these trail mixes do not have peanuts. So even if some of these values in this column are blank, I have one of those variables and the complement of that variable. On the other side, I'm going to put raisins and no raisins. Now, in this case, I just need a 2x2 grid, but if there were like 30 different types of raisins, it's possible that I could have more than 2 columns or more than 2 rows. And on the outside, I like to put 2 lines to remind myself of what's going on. This looks like a big equal sign. I'm supposed to put the totals on the outside of my grid. In these contingency tables, they're also sometimes called two-way tables. Do a nice job of keeping track of everything that could possibly happen. If I add everything together correctly, my grand total in the corner here should be 100%, or whatever my total number is. I have 50 of the trail mixes have peanuts, so the total for peanuts down here in the corner is 50%. It says 30% in total for raisins, so 30% in total for raisins, so that's going to go here. 25% have both peanuts and raisins. So and in stats is a spot where 2 things meet up. So that's where peanuts and raisins meet. I've got 0.25 if I'm doing this thing as a decimal, or 25% sit index. Let's fill in the rest of the values based off of this. 25% and 5% gives me 30. 25% and 25% gives me 50. 30 and 70 give me 100. I'm just making sure that everything adds up vertically and horizontally. 25% plus something gives me 70. I believe that's 45. And I can double check with this last value because whatever number I put down here, it should work both vertically and horizontally. So 5 and 45 add up to 50. 50 plus 50 gives me 100. I'm in pretty good shape. Now, when I'm using these tables to answer questions, I need to know what part of the table am I looking at, or what is it out of or given. In this case, it says, what is the probability that a randomly selected trail mix has peanuts, given that it has raisins? So I know that it has raisins. So when I'm using this table here, the only part I care about is this first row. When I'm answering this question, I know it's one of these 30% of trail mixes. So my denominator, I'm going to have 30% on the bottom. And of these 2 options that I have, either raisin trail mixes with or without peanuts, I wanted to know which ones had peanuts. And it looks like there are 25% inside of this subgroup that have what I'm looking for. I'm going to type this fraction into my calculator. I have this 25% divided by this 30%. And this gives me something like 0.833 repeating or 83.3% or so. Now, breaking this down a bit more, I can see where the formula actually comes from. So conditional probability formula is that the probability of A given B is the probability of both things on the top. And notice this was peanuts and raisins. This was both things on the top. Divided by, and on the bottom, I have the probability of that second component, the probability of B, in this case, raisins. So in general, when I'm looking at the probability of A given B, I'm taking the probability of A and B, and I'm dividing it by the probability of B. Whatever it is out of goes on the denominator, and on the top, you have both of those events together. Reading through the problem or just looking at the table, we see that 25% have peanuts and raisins. We see that 30% have just raisins. I'm getting exactly the same value here, except if I'm comfortable with this formula, I don't even need to use the table. I can just read the problem and see these results. I personally prefer using the table because when I'm using these formulas, it's easy for me to kind of set this up wrong and not know why I'm getting a number that's off. At least with the tables, I can visually see what those denominators are, but whatever process you're more comfortable with. So contingency tables are a nice way of arranging data to make it easy to find conditional probabilities.